So now we discuss continuity at a point. We say that the function f is continuous at x equals a if the following conditions are all satisfied. So dapat masatisfy itong tatlong conditions na to. First, f is defined at x equals a. Second, the limit of f of x as x approaches a exists. And third, these two values should be equal. Or in other words, f of a is equal to the limit of f of x as x approaches a. Okay? Otherwise, if at least one of these conditions are not satisfied, we say that the function is discontinuous at x equals a. If we look at this example, f of x equals 3x minus 1, clearly the function is continuous at x equals 1. Diba? You can sketch the graph without lifting your pen. Okay, so this function is continuous actually all throughout this graph, but we want to focus yun, sa x equals 1. Pero we can also say that the function is continuous at x equals 0, x equals 0.5, x equals 2, and so on. Now, this function, g of x, is discontinuous at x equals 1. Okay, so from the graph, what can you see? At x equals 1, you have a hole. Pag may hole kayo sa graph, it means that g of 1 is undefined. Let's look at another function, h of x. Clearly, h of x is discontinuous at x equals 0. Dun sa tatlong conditions, ano yung hindi nyo na-satisfy? So first, yung h of 0 is undefined. Second, what can you say about the limit of h of x? As x approaches 0 from the left, this is equal to negative infinity. While the limit of h of x, as x approaches 0 from the right, is positive infinity. Okay? The limit does not exist. So suppose you're asked to discuss the continuity of the function f of x equal to x cubed plus x squared minus 2. Okay? Ano ba yung domain ng f? Take note, ang function natin ay polynomial function. Ang domain ng polynomial function is the set of all real numbers. Okay? So, walang number or walang value ng x kung saan magiging undefined yung function. Okay? Next, let's get the limit of f of x at x as x approaches a, where a is any real number. This will just be equal to f of a. Okay? Actually, you can choose, suppose you want x to approach 1. As x approaches 1, so you have 1 plus 1 minus 2. This is equal to 0. The limit exists. You can choose x to be negative 5. So this is negative 5 cubed plus 5 squared minus 2. Again, the limit exists. Actually, the limit will exist for any real number and it is equal to f of a. Okay? So technically, the three conditions for continuity at a point are satisfied. Therefore, we say that f is continuous on the set of all real numbers. Okay? Next, we look at another function, this time, a rational function. Sige, let's check ano yung domain ng function natin. Since this is a rational function, the domain is the set of all real numbers except the number when the denominator becomes 0, and that is when x is equal to 2. Okay, so that's the domain of f. Take note, yung f of x can be written as x minus 2 times x plus 1 all over x minus 2. You can cancel, pero hindi pa rin pwede yung x equals 2. Okay? So, same sila ng graph ng f of x equals x plus 1, but you have a hole at 2. So, in this case, we say that f of 2 is undefined. But, if you get the limit of f of x as x approaches 2, take note yung f of x natin, di ba, can be simplified as x plus 1. So this is equal to 3. Okay, the limit exists. However, f of 2 is already undefined. Therefore, we say that f is discontinuous at x equals 2. So we have this remark that if f is a polynomial or a rational function and f of a is defined, then f is continuous at x equals a. So we look at another example. We want to discuss the continuity of the function at x equals 2. Okay? So natandaan nyo yung tatlong steps or tatlong conditions na kailangang i-check. So first, we get g of 2. Okay, when you say g of 2, get the value of the function g when x equals 2. And from the piecewise function, if x is equal to 2, then g of x is equal to 0. Okay, so the function is defined at x equals 2. Next, we get the limit of the function as x approaches 2. Okay, so ito, hindi at exactly 2. Yun yung g of 2. Pag kumukuha tayo ng limit, yan, we use this function. Ito yung function sa paligid ng 2 or very near 2, but not exactly 2. So you use that, get the limit of x squared minus x minus 2 all over x minus 2. Okay? Ito actually yung example natin kanina. Remember, yung numerator can be factored into x minus 2 times x plus 1 all over x minus 2. Okay, get the limit as x approaches 2. So you can cancel out x minus 2 and the limit is equal to 3. Okay? Now, yung third condition, di ba, dapat yung g of 2 should be equal to the limit of g of x as x approaches 2. Ang g of 2 natin ay 0 and the limit of g of x as x approaches 2 is 3. So since they are not equal, we say that g of x is discontinuous at x equals 2. Now, we can classify the discontinuities that we may observe or we may see sa mga functions. So first, yung first type of discontinuity is removable discontinuity. So kailan nagkakaroon ng removable discontinuity? If the limit of f of x exists. Okay? Nag-exist yung limit, hindi siya plus or minus infinity, pero f of a is undefined. Okay? Or f of a is not equal to the limit of f of x. We'll see later kung bakit siya tinawag na removable discontinuity. Next, we have an essential discontinuity. Okay, we have two types of essential discontinuity, yung jump essential and infinite essential. So when you say jump essential, ito, nag-exist yung limit, pero hindi sila equal. Okay? So, yung limit of f of x as x approaches a is not equal to the limit of f of x as x approaches a from the right. Okay, ano naman yung isang essential discontinuity? Infinite essential. Ito, if either limit of f of x as x approaches a from the left or from the right is plus or minus infinity. So, kung titingnan natin ulit yung mga illustrations kanina, ito, continuous at x equals 1. Ito, anong klaseng discontinuity ito? So, you have a whole at x equals 1. Okay, so in that case, we have a removable. So, pag whole lang, removable yon, discontinuity. G of 1 is, remember, pag removable, pwedeng undefined yung g of 1. And then, the limit of g of x as x approaches 1, kaya bang makita from the graph? As x approaches 1, so, yung value ng g ay palapit dito sa 2. Okay? So, the limit of g of x as x approaches 1 is 2. Or you can look at this. You can get the limit of this function. Sige, verify nyo ha. na ang limit ng function na to as x approaches 1 is equal to 2. Okay, so kung nag-exist yung limit, undefined lang yung g of 1, then removable discontinuity yun. Ito, obvious naman, as x approaches 0 from the right and from the left, okay, sige, sulat natin. Kung kukunin natin yung limit ng 1 over x, as x approaches, say 0 from the left, sige, from the graph, this is equal to negative infinity. So, kung may nakuha kayong infinity sa limit, then we say that this function has an infinite essential discontinuity at x equals 0. At x equals 0, ano nangyari? If you get the limit of h of x, as x approaches 0 from the left, 0. On the other hand, if you get the limit of h of x, as x approaches 0 from the right, okay, as x approaches 0 from the right, 1. Okay, so since the limits are not equal and obvious from the graph, na h of x has a jump essential discontinuity at x equals 0. Okay, sige, balikan natin tong removable discontinuity. Again, it's called removable because the discontinuity can be removed by redefining the value of f at a, so that f of a equals the limit of f of x as x approaches a. Okay, so katulad nito, you have a removable discontinuity at x equals 1. So how will we redefine? We define another function, say capital G of x, such that capital G of x is equal to small g of x, yung 3x squared minus 4x plus 1 all over x minus 1 if x is not equal to 1. Okay? So, ang gusto natin ay lagyan ng parang value dito para maging continuous. Kasi ito yung isang value lang naman to ang problema, di ba? Gusto natin na if x is equal to 1, ano dapat yung value para mapunan itong hole na to? G of x should be equal to 2. So, we redefine the function, yung capital G of x, for all values except at 1. Ito yung piece na nagde-define sa function natin. But once x equals 1, okay, matatakpan to. G of x or g of 1 is equal to 2. We want to discuss the continuity of the following function at x equals 1 and at x equals 2. What is happening at x equals 1? So first, let's get f of 1. So for f of 1, nandito yung x equal to 1. So etong function na to, etong piece ng function na to ang gagamitin natin. So you have 1 minus 2, that's negative 1, all over 2 minus 5 is negative 3, plus 2, negative 1. Okay, so f of 1 is positive 1. Next, get the limit of the function as x approaches 1. Okay. Pero kung titignan nyo, ang 1 ay parang boundary ng interval. Kung boundary siya ng interval, you have to get the limit as x approaches 1 from the left and get the limit as x approaches 1 from the right. Okay? Kasi magkaiba yung function sa right and sa left ng 1, ng x equals 1. So if you want first to get the limit as x approaches 1 from the left, aling piece dito ang nasa left ng 1? Okay? So when you say x less than 1, ito yung nasa left ng 1. Therefore, we will get the limit of this function. So 4x minus 3 as x approaches 1 from the left. And that is equal to 1. Next, getting the limit of f of x as x approaches 1 from the right. This time, etong part na to, sinasabi na for values of x greater than or equal to 1, or yung nasa right ng 1, ito yung piece na gagamitin natin. So we get the limit of x minus 2 all over 2x squared minus 5x plus 2. Okay? So what will that be equal to? You'll have negative 1 over negative 1, which is equal to 1. Now, since equal to, we say that the limit of f of x as x approaches 1 is equal to 1. Okay, now for the third condition, yung f of 1 ay equal sa limit ng f of x as x approaches 1. Okay? They are both equal to 1. Conclusion natin, therefore, f is continuous at x equals 1. Now, let's consider or check the continuity at x equals 2. Yung mga i-check natin. So, first, get f of 2. Okay, so 2 is greater than 1. Kaya, itong piece na ito yung gagamitin natin. If you substitute 2, you get 0 over 0. F of 2 is undefined because your denominator is 0. So, dapat dito pala kasama x not equal to 2. Okay, so we say that the function is undefined when x equals 2. Now, let's get the limit of the function as x approaches 2. So, you have x minus 2 all over 2x squared minus 5x plus 2. Sabi nga natin, this is 0 over 0. So, it's an indeterminate form. Let's try to factor the denominator. 2x minus 1, tama, times x minus 2. So, you can cancel out x minus 2. And this is equal to 1 over 2x minus 1. Getting the limit as x approaches 2, this is equal to 1/3. Okay? So, ano nga ulit yun? Kapag nag-e-exist yung limit, but f of 2 is undefined, it is discontinuous. The function is discontinuous at x equals 2. Anong klaseng discontinuity? We say that there is a removable discontinuity at x equals